In this lesson, we're going to talk about exponents. An exponent is part of a power. So if you look at this example that I have here, this is a power. And this is read as 2 to the third power. The 3 is called the exponent. It's the little raised number, right here, 3. A power also has a base number. And in this problem, the base is 2. So a power consists of a base and an exponent. And the exponent has a special job because the exponent's job is to tell us how many times to multiply the base by itself. So for example, 2 to the third power means that we're going to multiply the base of 2 by itself 3 times. So 2 to the third power is equal to 2 times 2 times 2. And then we can evaluate this expression to find the answer. So 2 times 2 is 4, times 2 is 8. So 2 to the third power is equal to 8. Okay, so again, a power is simply a number, which is a base, raised to a power, and that is called an exponent. So this is 2 to the fourth power. If we have it written like this, it would be 2 to the fifth power, or 3 to the sixth power. Now 2 to the third power has another name. 2 to the third power, we could say 2 to the third power, or we could say 2 cubed. Only when you raise it to the second power or the third power does it have a special name. So 2 to the third power could be read as 2 cubed. Anything to the third power could be cubed. Or anything to the second power could be read as squared. So this could be 2 squared. So if you hear the word squared and cubed, you know that they refer to a power. Cubed refers to the third power, and squared refers to the second power. Okay, so let's look at another example. Let's say that I have 4 to the second power, or 4 squared. What this means is I'm going to raise my base of 4 to the second power, which means I'm going to multiply it by itself 2 times. So 4 times 4 is 16. And that means that 4 squared, or 4 to the second power, is equal to 16. Okay, pretty easy. So let's look at another example, this time kind of going backwards. We're going to take a look at this problem, and I'm saying backwards because I'm going to write it out first. So this is the expanded form, which we call it because we're writing it out. So this is 6 times 6 times 6 times 6 times 6 times 6 times 6. So I want to take this, and notice how long it is and how long it took me to write that. I want to write it in a much quicker, easier format. So instead of writing all these 6's out, I know that my base is 6, and then I can figure out how many times am I multiplying that 6 by itself. 3, 4, 5, 6, 7. So a quicker, easier way to write this expression is to write it with the exponent of 7. So 6 times 6 times 6 times 6 times 6 times 6 times 6 is equal to 6 to the 7th power. Okay, so that's just kind of a way to show you how to go back and forth between the two forms, the expanded form and the power form here using the exponent. Okay, so that was just a quick overview of exponents so that as we get into order of operations, you'll be able to evaluate those powers.